In this video, I intend to introduce the idea of geometric sequences. So here's our first scenario. Suppose you put $1,000 into a bank account and the money gains 5% interest per year. Write a general expression to determine the total amount of money in the account in N years. So first, we start the first year. We know in year one, we have $1,000. We'll put $1,000 on our table. In year two, we have to take into consideration the 5% interest. So we'll take the 5 divided by 100, which is 0.05. And since we're gaining, we'll just add 1. So it's going to be 1 plus 0.05, which will be 1.05. So that will be my interest rate, or my common ratio. So on year two, we'll have our initial $1,000 plus $1,000 times 1.05. For year three, it's going to be the same scenario, but we'll add $1,000 that we're adding in plus 1,000 times 1.05 for year two, and then we'll have year three from the first year. So 1,001 times 1.05 squared. This process continues for n years. So we're going to say 1,000 that we're adding in plus 1,000 times 1.05 from the previous year plus 1,000 1.05 to the second power, all the way up to 1,000 times 1.05 to the n minus 1. So our expression will be 1,000 plus 1,000 times 1.05 plus 1,000 times 1.05 squared plus plus 1,000 times 1.05 to the n minus 1, and we're done. Suppose we have the geometric sequence 2, 6, 18, and 54. We want to write that as a geometric series. So our first step, we know our first term is 2. So we'll say G1 is 2. We need to find our common ratio. To do that, we can divide any term. So if we do 6 divide 2, we can see that's 3. If we do 18 divide 6, we can also see that's 3. If we do 54 divide 18, that will also be 3. So our common ratio is 3. So to write it out as a series, we will just write 2 plus 2 times 3 plus 2 times 3 to the second power plus 2 times 3 to the third power, and we're done. In our next example, we're asked to figure out the sum of the first 50 terms. So in a geometric sequence, the most important part is the formula. So we have Sn equals G 1 minus R to the n all over 1 minus R. So the first thing, G is my first term. I'll highlight that in yellow. And n is me my number of terms. G is my first term. Let's write this out. And then R is your rate, common ratio. Okay, so we'll highlight the first term in yellow. We'll highlight the common ratio in green, and we'll highlight the number terms in blue. And then number terms in blue. Okay, so we know our first term already, it's 1. We need to figure out our common ratio. And we also know the number of terms. That's just going to be 50 because it's told, gives us that in the problem. So to find the common ratio, we just do 10/11 divided by 1, since we already know this is a geometric series, and that's just going to be 10/11. To get the sum of the first 50 terms, you plug in 50. We plug in our first term, which is 1, parentheses 1 minus my common ratio, which is 10/11 to the 50th. All that over 1 minus 10/11. Like the 10/11 to 50 in blue, since that's my number of terms. We know the ratios, just common ratios. We'll do that in green, and we'll do the first term in yellow. From here, it's just a calculator problem. So I'm going to use my favorite calculator, GeoGebra. And the way we would enter this into GeoGebra, I would first type in 1, then make sure you hit the times. You can get that by clicking the keyboard and hit times. Now make a parentheses. Parentheses 1 minus 10. Do the fractions, hit divide. 11. Hit the arrow that goes to the side of it, and then hit the XY 50. Hit the arrow to go outside, and then divide 1 minus 10 divide 11, and we get 10.90. In the next example, we're given a sequence as a series of already written to a series. So we need to find the sum of the first so many terms. So what we can say from the equation, we have 1 and our last term 79. So if we notice, we can put an imaginary 1 above the 0.99, and then this would be the 0th term, so it'd be 80 terms. So we'll say n equals 80. And we use be consistent, and you still use that same blue for the coloring scheme. And we know my first term is going to be 1. So we'll say g equals 1. And then we just need to find our common ratio, which we can just do that by doing r equals negative 0.99 divided by 1, which is negative 0.99. Now we just plug into our formula, and we're going to use a calculator. So I'm going to say S80 equals 1, parentheses, 1 minus negative 0.99 to the 80th power, all that over, make that like times, 1 times 1 minus negative 0.99. From here, it's a calculator problem, so I'm going to use my favorite calculator, GeoGebra. So in GeoGebra, you just type in 1 times, hit your parentheses, 1 minus, use a parentheses since you have a negative, negative 0.99, close it, hit this button for the 80th power, 80, hit the right arrow a couple times, and then divide 1 minus, put parentheses around the negative, negative 0.99. And we get 0.277. We'll round that. You can round out to 77 or 0.2778. In our next example, we're given the first term and we're given the common ratio. So whenever it's written in a recursive form, we recall from when we study geometric series, the first term is always given as the first thing, and then our common ratio is, we'll highlight in blue, and let's say find the sum of the first 30 terms. So we're going to find the sum of the first 30 terms, so that's going to give me my number of terms to be 30. And our ratio is always in green. Okay, so from here, all the information is given to us, so we're just going to plug it into the formula. So S30 equals 10 times 1 minus 9 tenths to the 30th. We could also just use a decimal approximation, but since it's already written in fraction form, we'll just leave it as a fraction. All over 1 minus 9 tenths. From here, it's a calculator problem. So again, I'll use my favorite calculator, GeoGebra. So let's clear some of this old stuff out. You just click the dots, and that makes the old information clear out. So we're going to type in 10, then hit times, the parentheses, 1 minus 9 divide 10, arrow a couple times, and then notice that it puts the fraction into a parentheses automatically, 30. Hit the right arrow a couple times. And then we'll divide everything by 1 minus 9 tenths. And we get 95 point, rounded 3 decimals, 761. And we're done. The next problem is a word problem. A monkey is swinging from a tree. On the first swing, she swings through an arc of 24 meters. So we'll take that to be our first term. We'll highlight that in yellow. With each swing, she passes through an arc 1/2 the length of the previous swing. We'll take that to be our rate. Write an expression that gives a total length the monkey swings after n swings. So we'll say Sn. We'll just highlight the n with blue since we to be consistent. Equals 24 times parentheses 1 minus 1/2 to the n. All that over 1 minus 1/2. What is the total distance the monkey swings after 25 swings? So now we're being told what our end's going to be. It's going to be 25. So we'll say S25. And let's highlight our other information, 24. And then, there we go, equals 24. Parentheses 1 minus 1/2 to the 25. All that over 1 minus 1/2. Rate is in green, and there we go. From here, it's a calculator problem. So again, I'll use my favorite calculator, GeoGebra. And type in exactly what I say. 24, parentheses, 1 minus 1 divide 2, hit the right arrow, hit the box with a box above it to get the exponent, 25. I hit the right arrow, 2 times to get out the parentheses, and then divide everything by 1 minus 1 over 2. And to get a decimal approximation, in GeoGebra, if you click the arrow, it gives you the actual fraction. If we click the approximately equal to, we can see it's equal to approximately 48 swings. So approximately 48. So it's not exactly 48. Last example. Sloan went on a 4-day hiking trip. Each day, she walked 20% more than the distance she walked the day before. She walked a total of 27 kilometers. What is the total distance she walked on the first day of the trip? So our n's going to be 4. The rate has to do with the 20%. And we know that the total we traveled was 27 kilometers. We're trying to find out what my initial G is. So that's what we're trying to figure out. So first, let's convert the 20% into a decimal. So we're going to do 20 divided 100, which is 0.2. And we'll add 1 to that since we're talking about 20% more. So it's going to be 1.2. So that's my common ratio. Now we know that G of 4, we'll use a different color, we'll use pink, equals 27. So now we're going to plug into the formula. Say 27 equals G, which we don't know, parentheses, 1 minus 1.2 to the fourth. We know this is 4, pink, green, all that divided by 1 minus 1.2. Now, our next trick, we're going to take this piece and multiply to the 27. So we're going to say 27 times 1 minus 1.2 equals 1.g, parentheses 1 minus 1.2 to the fourth power. The next thing we're going to do is we're going to divide everything by 1 minus 1.2 to the fourth. 1 minus 1.2 to the fourth. So this is gone. So we're going to say G equals 27 times 1 minus 1.2, all that divided by 1 minus 1.2 to the fourth power. We'll plug that into the calculator and we're going to get an approximation. And it does say we're round to the nearest tenth of a kilometer. So we're going to use GeoGebra again. So I'll say this, we're going to do 27, parentheses, 1 minus 1.2, close it, divide, 1 minus 1.2, hit the exponent to the fourth, and we get approximately 5.0 kilometers. Hopefully that helps you get a little bit of understanding of the concept of geometric sequences.